Hey folks, and welcome to Iron Sysadmin. I have this crazy idea that I want to help you guys learn Linux, and the way I'm going to do that is by giving you some projects. But I'm not just going to hand them out like some professor that lives in an ivory tower. I'm going to walk you through them so you can actually try them, see how I do them, and then you can try them yourself. In today's episode of that little project, I'm going to take Red Hat Enterprise Linux and install it on this ancient laptop to use as a homelab hypervisor. You think it'll work? I think it'll work. So why am I using RHEL? Well, if you're going to learn Linux, if you're going to learn it for the purpose of maybe building career skills, I think you should do it on an enterprise operating system. Now, that's not to say that you can't go learn something like Ubuntu or Fedora or whatever. I just personally think that there's no reason not to learn on something like Linux. It's a great platform, and I'm not just saying that because of this hat on the wall. I'm saying that because I've been a Red Hat user long before I was ever an employee. Back in the late 90s, I picked up my first Red Hat Linux CD. Yes, CD, not DVD, not installation media on USB, CD at a computer show at a fairground, okay? So I've been a Red Hat user since like 1997, long before they were a company, let alone me working there. I've only been working for the company for about 5 years, right? So yes, I'm a RHEL fan. I'm a Red Hat fan. I'm a Fedora fan. And I'm going to show you on the stuff that I like. So, sue me. All right, so what I decided this first video should be is I'm going to help you build a home lab. Now, I know that sounds complicated, but trust me, it doesn't have to be. I'm going to make this as simple as possible. What I'm doing is I'm taking an old laptop. And I mean old, this thing is probably from, 2013 or so. And we're going to put Red Hat Enterprise Linux on it. Now, I know what your next question is going to be. How do I pay for RHEL? Isn't that stuff expensive? Well, it can be if you're an enterprise and you're using it in production and you want support. But Red Hat has this cool thing called the Developer for Individuals program. If you go to developer.redhat.com and sign up for an account, completely free, no credit card, anything like that has to be attached to it, you can get 1 year worth of subscriptions for Red Hat Enterprise Linux, 16 subscriptions. So you can run 16 RHEL systems. Now, I said a year. That's only because every year you have to renew it. It's still free. You can keep renewing it as long as you want for free. And you can use this in your home lab. You can use it for learning. You can use it for running in production if you really wanted to, but you don't get any support on it. So just keep that in mind if you're going to do it this way. So let's go ahead and get started. Like I said, I have my laptop over here. It's already installing RHEL. I am going to show you how to install RHEL, but I tried really hard to try to figure out how to capture the output from this thing in the installer, and it just wouldn't cooperate. I tried a mirror box. I tried HDMI outputs. Short of standing up a camera looking at the screen, which I don't think you're going to want to watch for the next 20 minutes, I just couldn't get it to work. So we're going to install RHEL in a VM on my home lab, just so you can see how the installation works. And I'm going to try to mimic what I did on the laptop in my virtual environment. So stick with me. I promise you it's going to be good. All right, so let's get started. Here we are looking at the web console for my home lab. And I'm going to promise you that when we're done with the setup on this laptop, you're going to have a very similar view, a very similar console to what I've got right here on your home lab. So what we're going to do is start out by creating a new VM. So let's click on the Create VM button. And I wanted to start you like scratch, like soup to nuts here. So we're going to give this thing a name, install from an ISO file. Okay, now I've got a RHEL 9.5 ISO right here. Now, you might ask, where do I get the RHEL 9.5 ISO? Well, there's a couple ways to get it. The way I got it was after I set up that account with the Developer for Individual subscription, I went over to access.redhat.com, went to the RHEL download page, and downloaded the ISO. So this is as clean as it usually gets. So what we're going to do here is we said local ISO. We picked the ISO. It detected that we're going to do RHEL 9.5. We're going to create a new disk image for it. Okay, now I'm going to make 2 disk images because the idea here is we're going to put our operating system on one disk. We're going to put our virtualization images on another. Okay, so and that's exactly how the laptop is set up. It has 2 drives in it, and that's why I wanted to emulate that here. We're not going to make them quite as big though. So the main disk we're going to make, 50 gigabytes. We're going to give it some memory. I'll give it 4 gig. Now, the actual machine has a lot more than 4 gig. I would recommend that your machine should have more than 4 gig. We're going to go create an edit. And the reason I'm doing create and edit is because I wanted to add that second disk, and I need to connect it to the right network in my home lab. Now, demo lab disk 2, and we'll make that another 50 gig. These are going to get deleted when I'm done anyway. We're going to add that. Okay, so now we have 2 disks. Okay, like I said, I want to switch this to a different network. Again, this is all my stuff. Doesn't matter for what you're doing. We're going to save that, and then we're going to run the thing. Click the install button, and it should bring us to a console where we can actually do the installation. Now, this is what you would see if you download the ISO and you're trying to install on a physical machine like I am over here. What you would want to do is download that ISO, and then there's a tool that I use called Fedora Media Writer. It's just a disk imaging tool. There's other tools that are out there that'll let you do this. I think Fedora Image Writer is pretty easy to use. You can get it on Windows, Mac, or Linux. So use another machine, go download the ISO, and then use Fedora Media Writer to select the ISO and write it to a USB stick. Now, the RHEL ISO needs, I think, like a 10 or 12 gig USB stick. So make yourself like a 16 gigabyte or more USB stick. They're getting pretty plentiful nowadays. The one I used was ridiculously large because it just happened to be one that I had laying around. Yeah, and write it to the ISO, and then you'll want to, write it to the USB stick, and then you're going to want to boot your machine off of that USB stick. If you're not sure how to do that, every BIOS is a little different. Usually at boot time, you hit like F12 or F2 or delete, and there's a bunch of different ways to try to get the boot menu up. Once you get the boot menu up, you tell it to boot off the USB stick. You should end up at a menu very similar to what you're seeing right now. So let's go ahead and walk through this. You can tell it to test the media and install if you want to. What that does is it knows the MD5 sum, the checksum of the installation media, and it'll check it before it does the installation. I trust the ISO because, like I said, I'm already using it to install on another machine. So I'm just going to say install. So now we're going to pick a language. This is all pretty straightforward. Pick what you speak or write or whatever. Then your dog barks. We're going to pick a destination here. Remember, we set up 2 different disks, so this gets to be a little bit tricky. What I want to do is put my virtualization images on the second disk and put my operating system on the other disk. So we're going to select both. Then we're going to click on this done button up at the top. Now, what you can do, if you don't have as complex of a disk setup as me, you click automatic and click done, and that'll automatically create stuff for you. What I'm going to do is click custom, hit done, and then there's still right here, if you do click here to create them automatically, that'll automatically create your partition layout. Now, that's an easy way to get it done. So here, I'm going to go ahead and click that and show you what happens. What this does is it took both disks and it sort of spanned them into one logical volume. That's okay, right? But I personally don't like to run things that way, especially in a physical system, because if one of those disks were to die, then you end up in a bad situation, right? So if I went and, well, here, let's just remove all of that. Okay, instead, let's make /boot. Now, /boot is where the operating system stores all of its bootloader information, right? This is the stuff it needs to make Linux run, right? So you're going to want that, obviously, and we're going to make that 1 gigabyte. Now, you can make it bigger, you can make it smaller. I think 1 gigabyte is the minimum that's recommended. Okay, now we're also going to add home. Now, home is where your home directory is going to live. Whenever you go to copy things to this server, whenever you have a new disk image to put up there, or an ISO file, or maybe you just need to download something that you're going to put into something in your environment in your home lab, your home directory is where that's going to live. So you're going to want to give that some space. I don't want to give it too much because my disk isn't very big. on this machine, the laptop, I made this like 20 gigabytes, but remember, I only made this disk 50 gig here, so we're going to make it 10 here. Okay, and then we're going to make another one. Another thing you need is what's called swap space. Okay, what swap space is it's basically virtual memory. Windows does the same thing. Mac, I'm sure, does the same thing. I've never looked into it. But basically, if the machine has things in memory that it needs to keep the memory footprint of, but they're not active, it'll put them into swap. Swap is a space on your actual hard drive that it stores those things. And then when it needs them, it can go get them and put them back into memory. That's why it's called swapping. It takes stuff out of memory and puts it to disk, and stuff from disk back into memory. Now, ideally, when you're building a system, you want to give it enough memory that it doesn't have to use swap much, because disk hard drives are very slow compared to memory, which is very fast. So taking things out of memory and putting it to disk is inefficient, but it's better than running out of memory. And it's better than having to reserve all of that very fast and more expensive memory in order to store things that aren't maybe in use at the moment. So that's why swap is still important, right? So you do want swap. There's a formula that you can use to figure out how much swap you need. If you did that automatic partitioning, it would have figured it out for you and you'd be fine. So I'm just going to give this, I don't know, how much did we said it had 4 gig of memory? We're going to give it 2 gig swap. All right, now the last thing we want to do is make that storage space for our virtual machines. Oh, the other thing I wanted to do here, hold on. So VDA1, we want only on there. We're going to change this volume group so it only uses VDA. Now we're going to make var libvirt images. And we're going to make that 50 gig all by itself. Now you're going to see here, it didn't make it 50 gig, it made it 37 gig. And the reason it did that is because it put it on that first drive. So now that we have selected that, we're going to make a new logical volume to put just the libvirt stuff on. We're going to call it libvirt. We're going to put it on VDB instead of VDA. Hit save. Okay, and now that's on the other thing. We click update. Okay, now the other thing we need to make is the root of the root drive for our Linux system. Put that in slash. And if we don't put a capacity in here, it'll fill the rest of the disk. Okay, to see it made a 36 gigabyte drive there, and put it in the rel volume group. The var libvirt images, we're going to also make that, see if we just make this bigger, 1 terabyte is a little excessive, but if we make it bigger than the size of the disk, it'll correct it to the size of the disk, so I think that's handy. Okay, now we're going to hit done. Now that'll lay out our disk for us, and if there were any issues in the way we laid it out, it would tell us before it gave us that confirmation window. It would say there's an error, and it would make us click a thing down here in this yellow bar at the bottom. Okay, now remember we said about how we can connect these, how the systems have to be registered using that developer for individual subscription. You can do that here during installation. The first thing that I should do here is go back and set my network. Okay, it's got its IP address. We're good there. Let's give it a host name. Apply that. If you're not connected to the network, when you go to do this registration here, then it's going to fail because it can't reach the network. And now when it registers, it's also going to register the system to Insights, which is a handy tool, which we're not really going to cover in this video. Just know that it exists. When this registers, it's going to connect to that. And whatever name you set as that host name is the name that's going to show up in your inventory. So you want to set it as something you can identify. Okay, I'm going to put in my credentials here. I'll probably blur them out, but this will be the username and password you set when you set up with the developer for individuals. Okay, we don't have to set a system purpose. We can let it connect to Insights and then click the register button. And this is going to go ahead and connect us. It's going to go and make sure we have entitlements through that developer for individual subscription. And it's going to connect us to Insights. And there we go. We're done. After you hit done, it's going to bring you back here. Now, this takes a little bit of time for it to figure out the repositories that are available to it from Red Hat. Once you connect it, right? Once you've connected it to your account, it goes and gets software from there. So it's going to get the latest and greatest updates at install time instead of what was on the installation DVD. So you have two options here. If you didn't want to connect it during installation, you don't have to. It'll read from the DVD, but only if you got the full DVD from Red Hat when you downloaded it. It's the full DVD installation. If you chose to install and chose to download just the, I think they call it the net install DVD, it won't have all the packages on it. But once you connect it to Red Hat, it won't matter because it'll get all the packages from there. So let's go pick software. So we're going to do a virtualization host because this is going to be a virtualization host. So we might as well install it as a virtualization host. We're going to tell it to install the virtualization platform. This is going to include all the stuff that makes it a hypervisor. Let's see here. We don't need RPM development, console internet tools. Container management. It's another thing that I think is important only because you can run containers on the same system you're running VMs on. And if you're going to do that, you need to install container tools. Now, this will install things like Podman and the tools that go with it. Okay, what else do we think we need here? I think that might be everything. You can, of course, go through more and add things if you want to. We're not going to do a graphical interface or anything. We're also going to want to add remote management for Linux. This is going to add web console, which is the thing that I was showing you earlier that I'm running my virtualization through. Okay, now we're going to hit done. You don't have to set a root password. In fact, I suggest that you leave the root account disabled, right? But it's going to let you set one here if you want to. Since we're not setting one, we have to make a user. We're going to make a user. We're going to make the user an administrator, and we're going to set a good, strong password for this user. Now, I recommend that later you come back and set an SSH key for this user if you intend to connect over SSH. If you only use web console, then the password is going to be probably your best bet to get in, but you probably want to make this machine inaccessible from the internet because password authentication can be broken, it can be cracked, and you don't really want to expose your home lab to that. Okay, now we're going to click the Begin Installation button, and this is going to go through and install all those packages we told it to download. All right, check it out. It's all done. We're going to hit the Reboot System button, and to be honest, this is kind of the end of the configuration of this particular system, but I wanted to show you one thing on that first boot. So after this thing boots up, it's going to bring us to a login prompt. And because we didn't install any sort of a GUI, we didn't install any X Windows system or anything like that. So here we are at that prompt. If you put this on a tower or a laptop or whatever, you'll get this on the console of the machine, right? So you notice that little message up there that says Web Console. Activate Web Console with systemctl enable cockpit.socket. We're going to do that, right? This is really, as far as I can think of at the moment, the only thing we're going to have to do at a command line to really get things up and working. So we're going to log in with our local user. Okay, and then we do sudo. Sudo is the way you get elevated privileges. It's how you run things as root. Remember when we installed, we set up our user and we check that box that says make this user an administrator? That's what this enables. So we're going to use sudo. Systemctl is how you control the system services on a Linux machine. So systemctl enable now tells it to start the service as well as enable it. Enable says started at boot, and now says do it now as well. Cockpit.socket. Put in our password, and that should enable Cockpit. Now, if we log back out, you'll see this little message at the top here that says you can access the web console at this URL, 10.0.0.168:9090. If you hit that with your web browser on your machine using whatever IP address it tells you, then you should be able to go and log into web console. So that's what we're going to do, except now we're done using our virtual machine, and we're going to use the lab laptop that I just installed RHEL on. All right, so I know I told you we weren't going to do any more console, but I just remembered a couple things we're going to have to do. All right, so there's two things that I wanted to do at the console quick before we actually got into web console. And one is we're going to copy a RHEL installation ISO up to the machine that we just built. Now, why would we do that? Well, because it's going to be a virtualization host, and we need to be able to install an operating system. Now, you can put ISOs for whatever operating system you think you're going to be installing. Maybe you're going to run a bunch of Windows VMs. Maybe you're going to run Ubuntu. Maybe you're going to run whatever. Copy those up instead. I'm going to use RHEL because, one, it's what I have handy, and two, because it's what I like to build homelab systems on. So we're going to SCP downloads RHEL 9.5, yada, 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 up to, and let me get the IP, 10.17 or 10.79. Now, this is the IP of the laptop that's over here, okay? Now, if you're coming from a Windows machine, I'm on a Linux machine as my client here, you could use a tool called WinSCP, or if you install the Windows subsystem for Linux, you can use OpenSSH, which is exactly what SCP is part of, to make this copy. Or PuTTY. PuTTY might do, I don't know. PuTTY's a good shell on Windows. If you're on a Mac, you've got all these tools already there. So you open up a terminal on Mac, you can SSH and SCP right from there. So, all right, so you have to use the username at, and then the host, and then it's going to say, I don't know what this host is. Are you sure you trust it? Yes, I do. Put in my ultra secure password, and then it's going to copy that ISO over. Now, remember I said whenever we copy ISOs up, it's going to put them in our home directory. By default, it puts them in your home directory. You could specify a path, but as a user, you're not going to have access to anywhere else on the machine except through that sudo tool that I showed you earlier. So once we're done copying this up, I'm going to SSH to the machine. We'll get a console on it, and I can copy that ISO to the right place, and there's one plugin for web console that we want to install. Maybe two. We'll see. All right, so the file's copied up. Now we're going to use SSH to gangriff at 68.10.79. Okay, now we're going to use sudo to do a couple of things. So let's clear the screen. Okay, we're going to copy that ISO. So the ISO is right here in my home directory, like I was talking about. Well, let's make an ISOs directory, I guess. Okay, so I know this might look complicated if you have no idea what you're doing at a console, but what I'm doing here is I'm using my elevated privileges to make a directory that I want to put my ISO files in. And all my ISOs, whenever I copy them up, I'm going to put them here so I know where to find them when I'm building new machines. Okay, now we're going to do sudo move the RHEL ISO file to var lib libvirt ISOs. Var lib libvirt is where libvirt, which is the daemon that does all the virtualization stuff on RHEL, lives. Like that's its working directory. Remember we made that subdirectory called images inside of there when we made the VM? I'll show you that in a second here. Oh, there we go. Okay. Okay, so now that's done copying. I told you I was going to show you where those images are going to live. Remember we made that other directory, var lib libvirt images, when we installed the system? There it is. And you can see it's got a terabyte on this machine. That's actually a physical hard drive spinning disk that's inside of this machine. Not the greatest thing to store your virtualization images on. You probably want a faster disk than that, but it's what this machine happened to have. So I'm going to see some performance problems from that, and that's why it took a while to copy that ISO file over. Okay, so the next important thing is some plugins for Web Console. DNF is the tool you use to install things from the software repositories that come with RHEL. We're going to use DNF to list cockpit -star. This is going to ask the DNF repository, show me everything that starts with the word cockpit, because all the plugins for cockpit start with the word cockpit. And here you go. You got a bunch of them. There's two that I care about. Install and then -y. This is like apt or apt-get on Ubuntu, just as an example. So we're going to install -y says yes, right? So don't ask me if I'm sure. We're going to install cockpit -machines and cockpit what is it, containers? No, podman. Okay, and it's going to install those and any dependencies that go with them. Remember, we installed container tools when we installed the system. That's Podman. And Podman is for, if you're going to run things in a container in this home lab, then you'll use Podman. If you're going to run things in a virtual machine in this home lab, you'll use libvirt and KVM. And these two plugins for Web Console are the things that are going to let us manage those things. Okay, now at this point, we should be done at the console. I know I said that once already. So we're going to log back out. And then I'm going to switch over to Web Console on our new machine. Okay, so normally, here, let me show you. Let me log out of here. All right, so here we are at the Web Console login for the system we built on the laptop here. And you can't see my address bar, but it's the 192.168 address that we used for in those SSH commands a minute ago. So we're going to log in with our user. And then it's going to bring us to Web Console on our brandy new lab machine. You'll see it says at the top here, limited access. That means that I have not activated my administrative privileges. So I'm going to click that button, and then it's going to ask me for my password again. And now we have full access to the system. Now, if we needed to get to the console again, we can click on Terminal down here, and then we can do console-y things right from here. But I told you we didn't need to do any more console stuff. So instead, we're going to go up to, I'm going to show you around Web Console a little bit, because this is how you're going to manage the system if you don't want to be at an actual terminal, right? So this is just an overview page. It gives you kind of an status for what the system is up to at the moment. And things you might care about. Storage, this is going to show us how much disk space we have, what's in use, how much load the disk is under, things like that. So important things to be able to monitor. Networking is where we're going to configure network interfaces. And I might go through and set up a bridge interface depending on how technical I think we want to get on all this, because there's two different ways that you can send network traffic to your virtual machines. One of them is there's a default network that comes out of the box with libvirt. Works, you don't have to do anything to configure it. And that's like an isolated, or I should say protected, network that can get to the outside using NAT, similar to how a router at your home would work to get you to the internet, except now this is like a little nested network inside of your virtualization infrastructure, similar to how things like VirtualBox would do it, or even VMware. If you have a NATed network, that's how that works. But you can bridge using the network interface that's in your home lab to your home network. So if you need to be able to get to your machines from your home network, you're probably going to want to use a bridged network instead. So I might show you how to set that up. Podman containers, like I told you, this is for managing containerized workloads, containerized things on your machine. If you were to create a container through here or create a pod, you can stand up a container. I don't think I'm going to go too deep into standing up containers in this particular example. What I wanted to show you is how to set up a virtual machine. So here we are. It's loading. Give it a moment here. Okay. Now, this is basically what you have out of the box with libvirt and web console. We can make a new VM using that ISO file that we created. It'll let us make disks wherever we want to put them on the machine. So, you know what? Let's just go ahead and make a VM. Okay, we'll call it the rel guest, and we're going to say local installation media. We're going to see if my path works out here. Look at that. There's my rel 9.5 system. It auto-detected rel 9.5. We're going to tell it to create a new disk image, right? I don't know. We'll give it 20 gigabytes. I'll go back to 4 gig of memory, I guess. Look, my system only has 7 gig of memory available. Like I said, it's an old laptop. We're going to go create and run. And what that's going to do is it makes the new guest automatically. Like I said, not the fastest system. Give it a minute. And there's the console. There it is, ready to install rel. Now, we're not going to go through the whole procedure of installing rel. I just want to show you how that works. But you might recognize that this is the same interface that I showed you when I installed that test system. Okay, now we should be able to... Oh, it's off the edge of the screen because I resized it, and we can't get to it. But there'll be a button to make this console full screen. I just kind of want to show you that it's working. There you go. So about that networking, let's see here. If we want to go add bridge, let's call it bridge 0, that's fine. And you need to attach it to a physical Ethernet adapter. Now this ENP4S0, I'm going to tell you from experience, that's my physical network adapter. This VRBR0 is the virtual network that's already configured for libvirt, and VNet0 I think as well is from libvirt. If you have a machine with lots of network interfaces in it, they're all going to show up here. You're going to have to know something about where you have things connected in order to set up this bridge. But I'm going to pick this ENP4S0. Bridge 0 is a fine name for this example. If you had a VLAN, it gets a whole lot more complicated, and I'm not going to go into that in this video. Okay, and then just like that, we've got a bridge. It automatically set an IP address on it, and it got an IP, right? So that's a good thing. What this is going to do is this machine is going to actually use that bridge as its network interface as well, because that's just how bridges work. Now, if I were to go back to virtual machines, and let's see, we don't really need this guy anymore. Did he die? What happened here? Where's his console? The console is just like missing. There's the console. There, okay. It must have been when it switched. Here, I'll just show you how this works. We're going to force this guy off. Because we don't have enough resources on this machine to do more than one machine at a time. Come on, force shutdown. There we go. We're going to make another VM. We'll call him guest 2. Do the same thing, local ISO. There's rel. Should auto-detect rel. There we go. Create a new image. I don't really care about the memory and everything. We're going to go create and edit this time. And I'm going to show you that that bridge is going to show up now as one of the network interfaces. So, oh, it already went to bridge 0 by default. That's handy. So there we go. This will bridge to bridge 0. Now, if I were to bring up this machine, I'm not going to be able to show you this in a quick time frame. But basically what this will do is it'll act like a machine that's directly plugged in to my home network, or the bridged network that this particular machine is on. All right, so there you go. I took an old laptop that I already had laying around and turned it into a homelab machine. Now, admittedly, it's not a very powerful homelab machine, and there are some other caveats with running your homelab on a laptop. One of the reasons I couldn't record this machine for its, from the console using my mirror box is because every time I closed the lid on it, it wanted to go to sleep. I couldn't find a way to turn that off. There was nothing in the BIOS that would let me turn that off. So if I was going to use this thing as a home lab, it would have to sit somewhere with the lid open forever. That doesn't seem like a really great use for a laptop. But if it's all you've got, you could make do, right? The other thing is it didn't have a lot of memory in it. I guess one bonus is it's got a built-in battery backup, though. If the power goes out, it'll run on its laptop battery. But I digress. Okay, so I hope you've enjoyed the video. If you do like this kind of content, go ahead and hit the like button. If you've got suggestions on other things you'd like to see me do as sort of an intro to Linux style project, because like I said, I think you learn from doing. And the way I learned Linux is because I just picked up some projects that I wanted to do 30 years ago and learned how by doing, and made a lot of mistakes along the way and became a better person because of it. And I think you can do the same thing. So maybe we'll do things like set up a media server, or maybe we'll make a game server to run like a Valheim box or some Minecraft, or I don't know. Let's pick something. If you've got an idea, leave it as a comment and we'll go from there. Thanks for watching.